Hey, what's up? It's Mr. J with SciOnTheFly. Today I wanted to talk a little bit about Science Fair, how it's infused in my classroom, and how it's run in my school. Stay tuned. So I offer Science Fair to all of my students. I teach 160 students plus every single day. Those students are all divided into 5 classes. And one of those classes is a GT class, of which a gifted and talented class, that I just make a requirement for them. Everybody else it's up for game for some extra credit. Regardless if you're doing this project for extra credit or for a grade, I ask them to start off by doing an interest survey. This interest survey asks questions about their hobbies, their clubs, their sports. What are they already involved in? It asks questions about their family members or friends of the family. Do you have any doctors in your family? Dentists, electricians, plumbers, bakers, bricklayers, candlestick makers. Who do you have in your family that might have some resources, that might have some equipment to help you with your project to get accurate results? This interest survey basically has one meaning, one purpose, one goal, and that's to help the student come up with a project that's specific, unique, and interesting to them. It's not just some random project that they went to online, they typed in Google and typed in Science Fair projects, and then the first thing that came up, that's what they're going to do. This is something specifically interesting for them. Interest surveys always have. I ask the students to always do an experiment. Experiments are projects that have something that you're trying to find out. They have variables, independent variables, dependent variables, controlled variables. I really encourage the students to stay away from any demonstrations, like a volcano. Everybody, can I do a volcano? Can I do a volcano? No, you can't do a volcano. It's not an experiment, that is a demonstration. The second thing I give is a timeline. This timeline is a broken down list of tasks to do by a certain date. This helps the student break it down into a much more manageable state instead of an overwhelming, here's the project. The first thing that you'll see is form number 1. Form number 1 is short, sweet, and to the point. I love it. It's asking questions. What is your Science Fair question? What's a possible title that you're interested in calling it? What's your hypothesis? I always ask the students to list an I think blank because blank statement for their hypothesis. I want to know, what do they think is going to happen? More importantly, why do they think that's going to happen? And lastly, I ask for a complete list of materials. What do you think you're going to need to gather before you start any of this testing? That all is in Form 1 and given by a certain date. Form 2 is all about research. Students are required to do a little bit of research for their project. Do a little internet searching, looking through some books at the library, but I really push, honestly, for some interviews. Finding a professional that's in that field that you can interview and ask questions, and that might also give you a little bit more resources later on down the road when you're ready to conduct your experiment. So research is vital. Along with form number 2, besides research, is a complete list of your procedures. What are you planning on doing to answer this question step by step? Break it down, be specific, this will help you in the end. Finally, form number 3 is all about the results. What happened? And that's exactly what results are. What happened? Give me the data, give me the bar graphs, the line graphs, the data tables. All of that goes in your results section. It's the meat and potatoes of this. That's what we're drawing for. Give me the results. What happened? The conclusion is slightly different. The conclusion isn't what happened. It's what did you learn from what happened. It's looking at the data. It's interpreting the bar graphs, the line graphs, and it's interpreting them to give you an answer of what you learned. That's your conclusion. I always begin a conclusion with, I learned that blank. And finally, what's your new question? Was there something else that came to mind whenever you did this project? Hey, this happened. I wasn't expecting this to happen. I wonder if... Give me another question that's related to your project. And that's how I break down Science Fair in my classroom. After the students complete their project, it's time for classroom presentations. I use this rubric to help me guide the students in helping them with their presentation. I find a classroom presentation is fantastic. They walk the entire class through what the project is, what happened, what did they learn. I ask the students in the classroom to offer up questions that they might have, that the judges might be asking for the Science Fair. I then allow the students to answer questions to them, and I ask them to tell them, what do you like about their project, their board, or their presentation. This really helps the students gain a little bit more confidence with their project, and it tells them that they're doing a really good job. So the day of the science fair, I ask all of the students to go to the computer lab. Now this is our holding tank. All of the students are asked to go here to be in one place, one location. I call them down 5 to 6 at a time, and then they come down to our cafeteria, which is where our science fair is taking place. I have a special seating area of about 10 or so chairs where they sit and wait for their judge to be available. Once a judge is available, they'll come up, introduce themselves, and then escort the judge to the project. Once they're at the project, they'll do the exact same thing that they did with the classroom presentations, only it's to the judge themselves. The judge will use the exact same rubric that I used in the classroom. During the presentation, the judge might be making notes on their overall presentation skills, eye contact, hand gestures, volume, posture, all of those things. After the students leave, they may hang around a little bit and judge the project on the overall idea, the overall originality, the overall neatness of the board. Using this rubric is how all of the ribbons and the overall winners will be decided. After they have judged one student, they make some final notes, and then they go get another student. This process continues and cycles through until all students have been judged. Once all students have been judged, the judges all come together and decide on their top 10 projects. Who are our top 10 winners? Overall, regardless of grade level, who had the top 10 projects? Those top 10 are the ones that will advance to regionals. Everyone else, based on our ranking system of a total of 70 points, depends on which ribbon you get. I hand out ribbons as a place score, not necessarily a place. If you get a blue ribbon, you get a blue ribbon score. If you got a red ribbon, you get a red ribbon score. A blue ribbon may be anyone who got a 60 to 70, you get a blue ribbon or a first place score, and so on and so forth. Once the judges have their top 10 picked, they help me hang all of the ribbons on a board. Everybody gets a ribbon because everyone is a winner in science fair. Later on, I open the doors to the public. All the parents, friends, family members can come to the science fair, see their son, daughter, friends, niece, nephews, grandson, whoever it is. They can see their project, see their award, and be very proud of their work. About 15-20 minutes into it, I make some announcements, explain how the ribbons were handed out, and then announce the top 10 winners. Each winner gets a ribbon, gets a medal, and gets the chance to advance to the regional science fair. So that's how we do science fair in my school, and that's how I infuse it into my classroom. I hope you enjoyed it. If you like what you saw, check out some of my other videos. It's Mr. J with SciOnTheFly, the place where science makes sense.